Hi class, for this one you get the disembodied voice. Anyway, I thought I'd walk through a problem with you because some of this might be alien to some of you. You're used to book problems, and actually the PMs used to be book problems, but those book problems aren't going to help you when you become a project manager. And so you need to take what you know and apply it to different kinds of problems. And so this whole idea of net present value really isn't all that complicated. What do you need to know for net present value? You need to know A, how much cash is going on in that 1 year, T, how much time is there, and R, what discount rate you need. And these are the only three things that you really need to know in order to solve any net present value problem. And the idea behind net present value problems is that money has time value. So what I need to do is set this up to figure out how much this is all worth. So the first thing we're going to do is set up T, because that's the easiest thing. It tells us it's 5 years. So I have year 0, then year 1, 2, 3, 4, 5. So here are my 5 years. Now, this is an investment. So I'm putting money in and I'm getting money out. So I need to figure out the cash flows. So what money is coming out? Well, the money that's coming out is the yield every year, which tells me is 7%. And also the way bonds work is you give somebody a certain amount of money. And what they do is they give you a percentage of that money every year. And then when the bond matures, which is at the end of the time period, you get all the money back. Now, there are fees involved, and this is the way they make their money. At least the investment house taking care of things. So why on earth do they have bonds? What you're really doing is giving somebody a loan. Now, bonds that are like municipal bonds or something like that, they tend to have very low interest rates in terms of returns because there's not a lot of risk involved. On the other hand, there are corporate bonds like startups can release bonds, and those are really high rates. Like you can get a 10% bond. The problem is that startup may not make it to the 5th year, in which case you lose all your money. And that's why they're called junk bonds, because they're based on promise, not anything real. So that's the money coming out, and how much do I have to put in? Well, there's the original investment and any fees. So now that I've set this all up, what I'm really trying to figure, what I need to do is I've got time down, these rates are here. So now what I need to do is put in what values A. All I need to do is figure out how to put these numbers into this table. So in terms of yield out in year 0, it's going to be 0. I'm not getting anything during year 0. And if you don't mind, I like to see my numbers lined up correctly. So what happens during that first year? Well, I'm going to invest $10,000, and I'm also going to pay $300 in fees. And for those of you who get lost in these zeros, one thing you can do in Excel is say format cells, format number, and I'm going to use the $1,000 separator. So what happens in year 1? Well, year 1, I get my 7% yield. So 0.07 times whatever this guy is. And so I get $700. Now in year 2, do I have to pay anything? Nope. Is anything else coming out? Am I getting my initial return back? Nope. So for the next 5 years, I'm going to get the same $700 all 5 years. And so I'm just going to make this equal. And so I get all $700 back. Now the interesting thing happens in year 5. What happens in year 5? Well, in year 5, I get my $10,000 back. And what happens in year 5? I have to pay fees. And so those fees are 3% times what my investment was, another $300. So how much am I netting every year? Well, it's just equal to how much money am I getting back minus the total money of what I'm putting in. And so negative means this is a loss for me. And so these are the cash flows every year. Now I need to figure out what's my rate of return on this. How much money am I really getting? Am I really going to get that 7%? No, because I'm losing money every year. And so one way to do it is to use IRR. Now, internal rate of return basically recalculates what that return is every year. Now, the equation is in the lecture. However, you can do this in an easier way, and that's that in Excel, there's actually a function called IRR. Then you just pick all the cash flows. It needs an initial guess, otherwise the algorithm just goes crazy. So I just guessed 10%. It doesn't really matter. And as it turns out, the rate of return on this is 5.8%. Now, why do I want to know this? Because maybe you have a better investment that'll give you 8% or something like that. And this is why you need to know these benchmark numbers, because they tell you where the opportunity actually is. Now, ROI is a little tricky, because what is ROI? Remember, it's the total I get in minus what I had to put into it divided by what my initial investment was. And so ROI can be misleading. Typically, people do ROI without taking into account the discount flow of money. And so this is why you have to be careful about the results it gives you. So let's do it that way. So it's equal to, well, what's the total amount of money I'm getting? And that's this. The reason why I'm saying plus is because this is minus, but minus everything I had to pay out divided by how much I had to invest. And I'm putting absolute value because I don't want it to be negative. And you have to count the fees. Anything you pay at time zero is how much it's costing you for the investment. So if I calculate it, it tells me ROI is 28.2%. Woo, that's a great investment. However, let's do ROI with NPV. Now, if I need to figure out what the NPV is, remember for investments, especially longer term investments, anything that goes past a couple of years, typically you use a long-term bond rate. And I'm not quite sure what it is right now, but I said it's okay to use 4%. So what's the NPV of this value? Well, it's equal to A divided by 1 plus 4% raised to the first power, and it comes out to this. And so I can do this the rest of the way and add everything up, or I can cheat. And that cheating is, in Excel, there's actually a function called NPV. And so first it asks you for the rate, which is 4%. What are the values? These guys. And so I have to subtract out what my initial investment is. And I need to put parentheses around these because I want the total sum, and divide by what my initial investment is. And okay, that's telling me 8%, but it's the wrong kind of number. Why it's currency, I have no idea. But I want a percentage. That's what I want to know. And in this case, I'll have one decimal place. So ROI tells me it's 7.7%. IRR is probably the more accurate way to do it. But the reason why people use ROI is just because it's a much easier calculation. And that's why they do it. 1 plus this raised to this. Now, one thing about Excel is I want to keep reusing this value over and over again. if I pull it, it's going to become L6 and go to 0. So the way you can do that is highlight the term you want and then hit F4 on your keyboard. And what these dollar signs mean is that it won't change that value of the cell. And so now what I could do is I could just pull down and look, I know how much Shohei Ohtani was actually making his first 3 years. Again, maintain your discipline. You maintain your discipline, these problems really aren't that bad. And now all of a sudden you see where what we learned in class we can apply to different problems. Okay, let's talk about the Bobby Bonilla problem. So what it tells you is you need to compare how much Bobby Bonilla is making out of this versus the Mets, who I actually despise because I'm a New York Yankees fan. It's horrible growing up in New Jersey with all those Met fans. Just horrible. Now, it's the same thing we talked about before. We need to know the cash flow, how much time, and what's the rate of return. Well, the problem tells us the rate of return is 4%. So there's one down. How do we do time? Well, it says it's 1996 and Bobby Bonilla is going to get paid the next year, so it's 1997. And so in terms of time, in this case, we're doing it by years. Yeah, Bobby Bonilla is getting paid for a long time, but not this long. Okay, so how do we do this? Again, maintain your discipline. How much is Bonilla getting paid in 1997? 0, 0, 0. And so he's getting paid zeros all the way up to 2011. Then 2011, he gets paid 1.2 million. 1.2 million. Now, one way to do this is to figure out what year it is. Just go equals this minus this. Since 1997 is our reference, we use our old friend function 4. And then I could pull this down to figure out what year I'm working with. And this goes out to 2025. Now, in terms of how much did Bobby Bonilla get paid? Well, I'm just going to move the Mets over here because I need to figure out. Now, I could do one of two things. I could do net present value, or I could do whatever. But really, the best way to keep track of this is do every year one at a time. Do every year one at a time, and you can figure out how this works. So Bobby Bonilla is going to get paid 1.2 million every year. There's one of two ways you can figure out the value. One is you can shortcut. You can figure out what the net present value is and add it all up. Again, this seems like a really long problem with all these entries, but when you use Excel, you can pull things down. And so it's this divided by 1 plus r raised to this value. R is not going to change. Yeah, it'd probably be easier just to enter 0.04. However, if you want to change the rates, then you can use the same spreadsheet. Let me open that up, and so just pull the whole thing down, sum the whole thing together. And we find out that instead of getting paid 5.9 million, Bobby Bonilla got paid 8 million. So by exercising a little patience, he got paid. Now, how much money did the Mets make? Well, here's the interesting thing about the Mets. The reason why they deferred all this is because they're going to get 10% off of Bernie Madoff on that 5.9. So if they're getting paid 5.9, 10%, it's equal to 5.9 times 0.1. Oops. Typo on my part. for those of you who don't know, let's see, Dr. Cho is having some hand issues. What ended up happening to me is too many fisticuffs when I was younger. And now my hands have some nerve damage and some of the ligaments are screwed up and I've got arthritis and other problems in my hand. So I'm looking at my left hand and I'm telling my wife, I need a new hand. And my wife said, where are you going to get a new hand? And I said, the second-hand store? Ba-da-da-boom. But anyway, so the Mets are actually making money all these years, and they're making all this money. And then what happens is when they have to start paying out to Bonilla, then you start subtracting it off. So instead of 5.9, it's equal to 5.9 minus this much. So let's see. Whoops. This number should be equal to this minus the 1.2. So the real trick here is this part, figuring out how much the Mets are making. But what this integrates in what we've learned in class, is, so the break even is somewhere around here. I'm okay if you just want to round this to 0. And so now the Mets are paying out negative because they're paying out to Bobby Bonilla. And so actually what you can do is just say equals minus 1 times this, because this is effectively what they're paying him. And so, because you're looking at the time value of money. So all these years they're making money, and then this naturally is 10% on this. And let's see, my mistake is, so 5.9, this is the previous number. And my math is still screwy. Okay, how much money is there? It's equal to, oh, I know what I'm doing wrong. Okay. So this is 5.9 minus this amount, whatever. And so, and it's multiplied by 10%. So what I need to do is 5.9 minus the 1.2 minus 1.2 and times 10%. And actually it'd be a lot easier just to do this. Equals 5.9 minus 1. Minus whatever this amount is. And then for the next one, instead of 5.9, it's the previous number. And so on. And the amount of money that the Mets are making is equal to, let's see, 24 times 0.1. So through all this time, the Mets are actually making money on the deal, and then they're paying out. And so when I sum all this up, I will leave the rest to you. I won't give you the total answer, but now you have an idea of how to do this Bobby Bonilla problem. Now, one thing people say is, gee, Dr. Cho, this isn't fair. You used Excel. Well, you can do this without Excel, which means you're going to need piece of paper and a calculator, and as you can see, you're going to have to do a lot of these equations over and over and over again. And I would really suggest you learn how to use Excel. For those of you who don't, it's a really good tool. It'll only take you an hour or two to learn. There are a ton of videos online and websites that'll teach you how to use Excel. Basically what Excel is a glorified calculator with more functions. Now, in terms of not being fair, let's say I didn't have a calculator and I had to do these calculations by hand. Well, you can still do it. It's just that the calculator doesn't make you any smarter. It just makes it more convenient to get around a lot of the busy work that is involved in problems. And for that matter, a lot of engineering is that way too. That's why actually I'm going to start a class called Math Without the Math, where you don't have to do this math anymore. I'm going to teach you how to use MATLAB, and we're going to focus more on problem solving and the conception of math, rather than having to actually do the tedious work of math. And the world's changing that way. I think the math department is going to come for my head. But honestly, I haven't done calculus in over 25 years. And why? Because we have computers to do that. Focus on the important stuff. If you have any questions, please let me know. And good fortune on your work.